We introduce an innovative way of testing the Standard Model based on how much dwarf galaxies are disturbed by gravitational tides from nearby larger galaxies, said Elena Asencio, a PhD student at the University of Bonn and the lead author of the story. The Fornax Cluster has a rich population of dwarf galaxies. Recent observations show that some of these dwarfs appear distorted, as if they have been perturbed by the cluster environment. This is because, according to the Standard Model, the dark matter halos of these dwarfs should partly shield them from tides raised by the cluster. The authors analyzed the expected level of disturbance of the dwarfs, which depends on their internal properties and their distance to the gravitatio. Galaxies with large sizes but low stellar masses and galaxies close to the cluster center are more easily disturbed or destroyed. They compared the results with their observed level of disturbance evident from photographs taken by the VLT survey telescope of the European Southern Observatory. The comparison showed that, if one wants to explain the observations in the Standard Model, said Elena Asencio, the Fornax dwarfs should already be destroyed by gravity from the cluster center even when the tides it raises on a dwarf are 64 times weaker than the dwarf's own self-gravity. Contradiction to the Standard Model. From this, the authors concluded that, in the Standard Model, it is not possible to explain the observed morphologies of the Fornax dwarfs in a self-consistent way. They repeated the analysis using Milgromian dynamics, MOND. Instead of assuming dark matter halos surrounding galaxies, the MOND theory proposes a correction to Newtonian dynamics by which gravity experiences a boost in the regime of low accelerations. This is not the first time that a study testing the effect of dark matter on the dynamics and evolution of galaxies concluded that observations are better explained when they are not surrounded by dark matter. The number of publications showing incompatibilities between observations and the dark matter paradigm just keeps increasing every year. It is time to start investing more resources into more promising theories, said Pavel Kroupa, member of the transdisciplinary research areas, modeling, and matter, at the University of Bonn. We expect to find more disturbed dwarfs in other clusters, a prediction which other teams should verify. Participating institutions and funding. In addition to the University of Bonn, the study involved the University of St Andrews, Scotland, the European Southern Observatory, ESO, the Univer. The study was supported by the University of Bonn, the UK Science and Technology Facilities Council and the German Academic Exchange Service. Make a difference. Sponsored opportunity. Story source. Materials provided by University of Bonn. Note. Content may be edited for style and length. Journal reference. Elena Asencio, Indranil Banik, Stefan Miski, Aku Venhola, Pavel Kroupa, Hongsheng Zhao. The distribution and morphologies of Fornax cluster dwarf galaxies suggest they lack dark matter. Monthly Notices of the Royal Astronomical Society, 2022. 515. 2, 2981 doi. 10. 1093, MNRAS, Stack 1765. Cite this page. University of Bonn. Signs of disturbance in nearby dwarf galaxies indicate an alternative gravity theory. Science Daily, the 5th of August 2022. ift.tt/.8g. University of Bonn. 2022, August 5. Signs of disturbance in nearby dwarf galaxies indicate an alternative gravity theory. Science Daily. Retrieved August 5, 2022 from ift.tt/.8g. University of Bonn. Signs of disturbance in nearby dwarf galaxies indicate an alternative gravity theory. Science Daily. ift.tt/.8g. Accessed August 5, 2022. Thanks for watching. Please subscribe my channel for more videos.